Hey guys, in this new video, we're going to take a look at acid and base titration curves. So let's take a look at this image. We're going to say here, the shape of a titration curve involving an acid and a base makes it possible for us to identify the equivalence point. Now, we're going to say the equivalence point is where we have equal amounts of acid and base together. It's when we have equal moles of both. So we'll have equal moles of acid and base. That is called our equivalence point. They basically neutralize each other because they're equal in amount. If we take a look at this curve, we can say here that it looks like we're beginning around a pH of 1. Now that pH is very, very low. So that would indicate that we're dealing with a strong acid initially. And take a look. Over time, we're adding more mLs of the titrant. So basically what's happening is we have a jar or a beaker of acid and we're dropping, drop by drop, some base. So we're saying that the strong acid is being titrated by a base. So the base is our titrant. And we're saying over time we can see that the pH is gradually increasing. Then all of a sudden, boom, it goes straight up. And there's a huge change in the pH. We're going to say because around this volume where we see the big jump in our pH, this represents the equivalence volume of our base. So it looks like once we get to 35 mLs, we've reached the equivalence amount, mLs, of the base we need to get to the equivalence point. So it shoots straight up. So this is the steepest climb. So the biggest change in pH happens around the equivalence point. We're going to say halfway up this increase, we have this dot right here. That dot right there represents our equivalence point. At that exact moment, we have equal amounts of acid and base together. And we're going to say here, it looks like the pH is 7 exactly at the equivalence point. Okay, so this is our equivalence point right here. And we're going to say here, because the equivalence point is exactly at 7, a pH of 7, this tells us that a strong acid is being titrated by a strong base. Because when they're titrating each other, when we get to the equivalence point of a strong acid and a strong base together, the pH is always equal to 7 under normal conditions. And we're going to say here, we see that it keeps climbing, the pH keeps climbing. After the equivalence point, we have what's called an excess of strong base. And remember, above 7, you're basic. So once we get past this point right here, this equivalence point, all the acid is gone. So all we have now is just additional base being added to our beaker of solution. So this is exactly how it works. So this would represent a pH titration curve of a strong acid and a strong base being mixed together. Now, we'll learn later on that we don't only have this type of titration. We could titrate a strong base with a strong acid. So we're starting out with strong base. So that means we're going to start out fairly high, maybe around 13. And we're going to add strong base. And over time, the base will decrease and decrease. And we'd say here, this red curve represents the titrating of a strong base with a strong acid. It would also give us a pH of equal to 7 around the equivalence point. Well, so these are two strong species titrating each other. We're also going to learn later on that we have a strong species titrating a weak species. As a result, the pH at the equivalence point will be greater than 7 or less than 7.